Okay, hello friends. In last lecture, we have studied about what is solution, type of solution, units of concentration, and solubility of solid in liquid, where solid was solute and liquid was solvent. Now, moving further, in today's lecture, we are going to study solubility of gas solute in liquid solvent. Here gas is solute, liquid is solvent. Okay, so this solubility is affected by three factors. Like we have seen in last lecture, solubility of solid in liquid, that was also affected by three factors. Here solubility of gas solute in liquid solvent is also affected by three factors. First one is same, nature. As we discussed earlier, non-polar solutes are soluble in non-polar solvents. I am taking an example here. HCl gas. We have discussed earlier that HCl is polar compound. So HCl gas is polar. So in non-polar solvent like CCl4 carbon tetrachloride, it is not soluble, insoluble. But HCl is highly soluble in polar solvents like water. Okay. Now suppose the question is that why HCl is soluble in water but not soluble in CCl4. So you have to answer it like this, that HCl is polar compound, and CCl4 carbon tetrachloride is non-polar compound. So HCl gas is not soluble in CCl4, but it is soluble in water because water is polar compound. Okay. Now there is an important point. All the monoatomic gases as well as gases having same type of atom in it are non-polar. Now what is monoatomic gases and what do you mean by gases having same type of atom in it? I am going to discuss it here. Monoatomic gases, like I am taking helium gas here. Helium atom do not combine with any other atom. It is inert. So it is monoatomic gas. Like that, neon, it is also inert gas. So it is also monoatomic gas. And same type of atoms in it. Gases having same type of atoms in it. Example of that is hydrogen gas. Here H2 molecule that consists hydrogen and hydrogen, two atoms, both are same atoms. So this type of gas H2O2 N2 F2 Cl2, whichever you want to take, that gases are taking place here. So that gases are non-polar in nature. Okay. Again, this point, monoatomic gases like helium, neon, argon, inert gases that are non-polar in nature, and gases having same atom in it that is also non-polar like H2, N2, O2, etc. Now, second factor is temperature. Now, as we know, with increase in temperature, volume of gas increases. This is called expansion. Due to this, with increase in temperature, solubility of gas decreases. Again, With increase in temperature, solubility of gas in liquid decreases. I am taking an example here. Suppose you have a glass of water, normal water I am talking about, and you boil it using burner. Okay. You will first observe some bubbles here on the outer surface of liquid. You will observe some bubble. What are these bubbles? These bubbles are nothing but soluble gas in this liquid. They are trying to get out of the liquid. Okay. જે ગેસીસ લિક્વિડની અંદર ડિસોલ્વ થયેલા હશે, ઓલરેડી ડિસોલ્વ થયેલા હશે, એ બહાર નીકળવાનું ટ્રાય કરશે અને એ બબલ ફોર્મેશન કરે. That's why in some book there is a term called gas are bubbled out from liquid. બબલ આઉટનો મિનિંગ શું? બબલના ફોર્મમાં એ બહાર નીકળી જાય છે ગેસ. ઓકે. સો with increase in temperature, solubility of gas decreases. I told you an easy example. You can do it at your home if you don't know. Now, third factor. With increase in pressure, solubility of gas in liquid increases. Pressure increases, solubility increases. Example is soda water. As we know, the cold drinks and soda that are nothing but highly pressurized gas in water. Okay, so the pressure they apply, that is due to they want to increase the solubility of gas. Soda water is already we know carbon dioxide in water. So to increase the solubility of this carbon dioxide in water, they pressurize the carbon dioxide on the surface of water. Okay. Now this is very important question. Listen to me very carefully. As I told you, there is one question of 4 marks from this chapter is there according to current paper style. Okay. In this 4 marks, they can ask theory or some example. So there are 7 theories. 7 theories in this chapter that can be asked in 4 marks, and 7 or 8 examples are there. From this 7 theory, this theory, Henry's law and its uses is one of them. So it is very important question for 4 marks. Okay, so learn it very carefully. So the question is like this: explain Henry's law and its uses. The first point, Henry's law shows quantitative relation between pressure of gas and solubility. Henry's law find out એટલા માટે થયેલો કે આપણને ખબર હતી પ્રેશર સાથે solubility of gas increase થાય છે, but કયા રેશિયોમાં increase થાય છે that we were unaware of. That's why Henry's law, he was the first who found out the quantitative relation. And I find out કર્યો exact relation કે કયા રેશિયોમાં solubility increase થશે. Okay. This law states that at a constant temperature, the solubility of gas in liquid is directly proportional to pressure of gas. Again, at constant temperature, the solubility of gas in liquid is directly proportional to pressure of gas. Meanwhile, another scientist called Dalton, you must be aware of. He found out that partial pressure of gas over liquid is directly proportional to mole fraction of gas that is soluble in liquid. What this statement means, I am going to tell you. Just repeat it once. Partial pressure of gas over liquid is directly proportional to mole fraction of gas that is soluble in liquid. Now, to understand that, let me show you an example. Suppose I have a liquid here and this beaker is sealed. It has cover on its top. Okay. Now this portion is filled with air and this is, I am taking water here. Okay. So what Dalton is saying here, partial pressure of gas over liquid means the pressure of this gas, આ જે ઉપરનો પાર્ટ છે એનું pressure of this air is directly proportional to mole fraction of gas that is soluble in liquid. એ શાના directly proportional છે? Mole fraction of gas soluble in liquid. આ લિક્વિડની અંદર જે બી ગેસ સોલ્યુબલ થયેલો હોય એના મોલ ફ્રેક્શનની સાથે ડાયરેક્ટલી પ્રપોઝનાલિટીમાં છે. અગેન પ્રેશર કયું કીધું? જે ઉપર છે એનું પ્રેશર, અને મોલ ફ્રેક્શન કયું લીધું? જે લિક્વિડની અંદર ગેસ ડિઝોલ્વ થયેલો છે, એ લિક્વિડની અંદર ગેસ ડિઝોલ્વ થયેલો છે એનો મોલ ફ્રેક્શન. ઉપરનાનું નથી મોલ ફ્રેક્શન. જે અનડિઝોલ્વ એર છે એનું પ્રેશર અને ડિઝોલ્વ એર છે એનો મોલ ફ્રેક્શન. આ ટર્મ યાદ રાખજો, ઇમ્પોર્ટન્ટ છે. ઓકે, they both are in directly proportionality. So આ બંને સ્ટેટમેન્ટ you have to mention in your exam. You have to answer it like this only. You will get full marks, 4 out of 4. So again from starting I am continuing. And this law શું કરવા find out થયેલો? It shows quantitative relation between pressure of gas and solubility. Second point, એનો પોતાનો શું સ્ટેટમેન્ટ હતો? હેનરીનું સ્ટેટમેન્ટ. His statement was this: at constant temperature the solubility of gas in liquid is directly proportional to pressure of gas. એના સિવાયનો બીજો એક સાયન્ટિસ્ટ આવ્યો. Meanwhile, another scientist, Dalton, he told us that partial pressure of gas over liquid is directly proportional to mole fraction of gas that is soluble in liquid. આ બંને સ્ટેટમેન્ટને કમ્બાઈન કર્યા. Now combining these both statement we get common form of Henry's law. This is common form, and it is nothing but statement of Dalton's. Okay, એનું એ સ્ટેટમેન્ટ નીચે લખવાનું છે. Partial pressure of gas over solution is directly proportional to mole fraction of gas in the solution. એનું એ જ સ્ટેટમેન્ટ છે, common form of Henry's law. Now this shows the mathematical form of Henry's law. P, that is partial pressure of gas, x, that is mole fraction of gas. કયો ગેસ લીધો આપણે મોલ ફ્રેક્શન માટે? gas in solution. This was in upper layer. Okay, so this is mathematical form. And listen to me very carefully. Whenever you are attempting this question, mention what is p and what is x. P here is small and x is capital. What is p and what is x, that you have to mention, otherwise marks will be cut down. So you have to mention without forgetting what is p and what is x. Now if I remove this proportionality by putting some constant here, kh, p is equal to kh x, where kh, this constant, is called Henry's constant. Now if we draw a graph of pressure versus mole fraction, pressure and mole fraction, એ બંને વચ્ચેનો ગ્રાફ ડ્રો કર્યો. So we'll get a straight line, અને આ લાઇનનો slope of this line, that is equal to kh. Okay, this is written here. If we draw a graph of partial pressure versus mole fraction, we get straight line and slope of that line is equal to kh. Now value of this constant kh, આ kh ની value એ કોના ઉપર ડિપેન્ડ રાખે? So it depends on nature of gas. બધા ગેસની વેલ્યુ અલગ અલગ હોય છે. બુકની અંદર એક ટેબલ આપેલું છે, ટેબ્યુલર ફોર્મમાં થોડી વેલ્યુઓ આપેલી છે. વેલ્યુઓ યાદ રાખવાની જરૂર નથી. Okay, you don't have to remember the values. Just remember these 2 points. Value of kh, that depends on nature of gas, and temperature. At different temperature this value changes. As temperature increases, kh value increases. Temperature જેમ increase કરીએ એમ kh value increase થાય છે. And solubility decreases, that we already discussed in factors. ફેક્ટર્સની અંદર ઓલરેડી ડિસ્કસ કરેલું. ટેમ્પરેચર ઇન્ક્રીઝ થાય તો સોલ્યુબિલિટી ડિક્રીઝ થાય. ઇન ફોર્મ ઓફ બબલ્સ, ગેસ ઇઝ ટ્રાઇંગ ટુ ગેટ આઉટ ફ્રોમ લિક્વિડ. ઓકે, એ આગળ ઓલરેડી ડિસ્કસ થઈ ગયેલું છે, એનું એક સ્ટેટમેન્ટ છે આગળ. ખાલી આ kh વાળું વધારે અંદર છે. ઓકે, with increase in temperature kh increases and solubility decreases. Okay, so this was Henry's law. Now uses, 3 use છે. There are 3 uses of Henry's law, and these are very easy uses. પહેલો use, you have already seen that to increase solubility of carbon dioxide in cold drinks and soda water. કોલ્ડ ડ્રિંક્સ અને સોડા વોટરની અંદર CO2ને વધારે ડિઝોલ્વ કરવા માટે પ્રેશરાઇઝ કરે CO2ને. સો ઇટ ઇન્ક્રીઝિસ ધ સોલ્યુબિલિટી ઓફ CO2. ઓકે, એનો પહેલો યુઝ છે. બીજો યુઝ છે બેન્ડ્સ. નાઉ વોટ ઇઝ બેન્ડ્સ? જસ્ટ લેટ મી શો યુ સમ પિક્ચર્સ હિયર. Okay, now look here, scuba divers, that you must be knowing. Scuba divers નો શું કામ હોય, scuba divers શું કરે એ તમને ખબર હશે. I am assuming that. Now when scuba diver is deep inside the water, waterની અંદર નીચે હોય, at that time he will be under pressure of air and water. પ્રેશર કયું હશે આની જોડે? એરનું પ્રેશર પ્લસ વોટરનું પ્રેશર. સ્કૂબા ડાઈવર, આ મેં ડ્રોઈંગ કરેલું છે, પાર્ડન મી ફોર દેટ, બહુ ખરાબ ડ્રોઈંગ છે એનું. જ્યારે સ્કૂબા ડાઈવર deep inside, he is in deep inside the water, at that time he will be pressurized due to air and water both બંનેનું પ્રેશર એના ઉપર અપ્લાય થશે. Due to this, the oxygen, that is the required oxygen, it is in large amount for this scuba diver. એને ઓક્સિજનની વધારે જરૂર પડશે. Why? Because as we know earlier, with increase in pressure, solubility of gas increases. તો આગળ પ્રેશર એર અને વોટર બંનેનું છે. સો એના બ્લડની અંદર ઓક્સિજનની ડિમાન્ડ વધારે થશે, ઓક્સિજન વધારે ડિઝોલ્વ થશે. આ પ્રેશર ઇન્ક્રીઝ થયું, દેટ્સ વાય. ઓકે, નાઉ in this second situation, when he tries to come out of the water, જ્યારે વોટરની બહાર આવી જાય, એકદમ બહાર આવી ગયો. Now at that time the pressure is suddenly decreased here. જે વોટરનું પ્રેશર હશે એ આગળ જતું રહ્યું. ખાલી હવે એના ઉપર કોનું પ્રેશર છે? એરનું પ્રેશર. સો પ્રેશર ઇઝ વેરી લેસ દેન ફર્સ્ટ કન્ડિશન. પહેલી કન્ડિશન કરતાં આગળ પ્રેશર બહુ ઓછું થઈ ગયું. ડ્યુ ટુ ધેટ વોટ હેપન્સ ઇન અવર બ્લડ, there are some bubble formation of nitrogen gas. આપણા બ્લડની અંદર પ્રેશર ઓછું થઈ ગયું, એના લીધે નાઇટ્રોજનના બબલ્સ ફોર્મ થાય. એન્ડ આ બબલ્સ, ડ્યુ ટુ ધીસ બબલ, our arteries or capillaries gets blocked. બ્લડને આગળ જવા નહીં દે આ બબલ્સ. વચ્ચે વચ્ચે બબલ્સ ક્રિએટ થઈ જાય in our arteries or capillaries of blood. So it stops the blood. So due to this, scuba divers can die here. This condition, this medical condition is called bands. આ જે કન્ડિશન થાય એને બેન્ડ્સ કહેવાય. Look here. Scuba divers feels very high pressure. બ્રેકેટની અંદર મેં લખેલું છે સાનું પ્રેશર, એર પ્લસ વોટર, when they are deep inside the water. Now when they come out of the water, suddenly pressure decreases. This leads to formation of nitrogen bubbles in blood, and these bubbles blocks blood capillaries. This condition is called bands. એના લીધે સ્કુબા ડાઇવર્સ મરી જઈ શકે. To avoid that, for prevention, scuba divers carries some oxygen cylinders with him, and in that oxygen cylinder there are 3 gases. First one is 11.7% helium gas, 56.2% nitrogen gas, 32.1% oxygen gas. Okay, a percentage you have to remember, because this was the MCQ in previous board examination related to this percentage. Okay, now third use is anoxia. It is also a medical situation. Now at high altitudes, pressure of oxygen gas decreases. Means જેમ what does that mean? Means at higher level from ground, oxygen is less, available oxygen is very less. So due to that, hill climbers gets low oxygen at the height. So that leads them to weakness and unable to think. Oxygen blood ની અંદર ઓછો થઈ જાય, so that leads them to weakness and unable to think. અશક્તિ આવે અને કંઈ વિચારી ના શકે. This medical situation is called anoxia, and to avoid this problem, they carry a cylinder which are filled with 11.7% helium, 56.2% in nitrogen, and 32.1% oxygen. આનો આ પોઈન્ટ અહીંયા આગળ લખવાનો છે પછી. ઓકે, so these are 3 uses of Henry's law. And this was the second lecture. Now for homework you have to write the Henry's law, explain it, and write down its uses. This question is very important. Prepare it with